Two of the following videos are true, while the other one is trash. Can you spot the fake? Season 4, Episode 3. Round 1, let's begin. First up, take 4 magnets like these and place them spread out on a table with all north poles facing upwards. Then flip the polarity of 2 magnets so that their south poles are facing up. Then combine them into a square like this so they have alternating north and south poles. Next, take some pencil graphite and break off a small piece. If you place that graphite directly in the center of the magnets, you'll see that the graphite will levitate above the magnets. This device has 2 tubes and a chamber below that you can seal with this plastic pane. If I place a few ice cubes inside the container and seal it up, the cold ice cubes cause the air to contract. You can see this more clearly if I burn some incense just to produce some visible smoke. When I blow it out and stick it near the entrance of the tube, you can see that the smoke is being pulled down the tube by convection currents. This is a 2-liter soda bottle filled with salt as well as a bunch of blue and white plastic beads. I'll add about 250 milliliters of water to this bottle and shake it up so that the water becomes saturated with salt. Next, I'm going to add 70% isopropyl alcohol until the container is almost entirely full. Once that's done and I seal it, I can now shake the bottle vigorously before placing it down, and you see that the less dense white beads float to the top, while the denser blue beads sink to the bottom. Then if I leave this bottle at rest, the white beads will slowly sink and the blue beads will slowly rise until they meet in the middle. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. It turns out it's true that adding isopropyl alcohol to salt water will cause the beads to behave like this. Looking at the end result, the clear liquid above the beads is the isopropyl alcohol, which has the lowest density, followed by the white beads, then the blue beads, and at the bottom is the salt water with the highest density. However, when you shake it up, the isopropyl alcohol and the salt water will temporarily mix. The density of this mixture is between that of the blue and white beads. However, this mixture of isopropyl alcohol and saturated salt water aren't soluble with one another. So, over time, the isopropyl alcohol and the salt water will separate. That brings the isopropyl alcohol back to the top and causes the salt water to fall back to the bottom. Did you think you could levitate something without electricity? Well, nice job, because this is legit, and it works even better with a thin piece of pyrolytic graphite like this, which is basically a more pure form of graphite. This showcases diamagnetic levitation, where the relatively strong diamagnetism of this material is repelled by the magnetic field of the magnets. That means ice cubes won't cause smoke to be sucked down the tube. I actually swapped out the ice cubes for a lit candle. The heat from the candle causes air to rise out the tube, which does pull the smoke down the other one. So convection currents did cause the smoke to fall, but the ice cube portion of the screen was just overlaid to make it look like they were responsible. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 2. Latex, like that of the standard air balloon, is quite sensitive to large temperature changes. That means if I touch an ice cube to the surface for a few seconds, it'll cause the balloon to pop, even when you're only pressing gently. First, take a large metal ring like this and a bead necklace and tape the necklace to a surface a few inches apart so it can hang freely like this. Next, I'm going to drop this ring in a very particular way by simply releasing my thumb, which will cause the ring to fall. When I place the metal ring around the bead necklace and perform this drop from the top, the ring won't hit the table because the necklace beads will tie around the metal ring, holding it up. First, start with 2 large books. I'm going to place some rope in between each book towards the spine about halfway through. Next, I'm going to overlap the pages of these books, alternating a few pages from each side at a time. Once they're completely overlapping, I'll tie one string to a heavy cinder block, and I'll tie the other string in a knot to make a handle. Even though it's just the friction from the overlapping pages, I can pick up the string handle and use the books to lift the heavy cinder block. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. Dropping this ring in this way actually will work like this, and it's honestly really cool to see. The way the ring rotates as it falls yanks the bead necklace in such a way that it does tie itself to the ring. I was actually surprised at just how consistent this works once you have the right setup. And by the way, you do need to release the ring perpendicular to the width of the necklace in case that wasn't clear. It's also true that overlapping the pages of 2 large books allows you to lift quite heavy objects. It's the tremendous amount of static friction between the pages that makes them nearly impossible to pull apart with your hands. That means an ice cube won't pop a regular air balloon. The culprit was a usual suspect, the limonene spray that I used in a previous episode. Instead of a regular ice cube, I quickly sprayed the ice cube with the limonene while you weren't looking. Limonene actually dissolves the latex of the balloon, causing it to pop. And yes, this is the same reason why orange and lemon peels can pop balloons when you squeeze them. Their peels contain limonene, but in much smaller amounts. Here's a quick recap to help you follow before moving on to the next round. Now it's time for the final round, round 3. I attached this laser pointer to a stand so that I can aim it at the wall, and this is an opaque sheet with a few very thin transparent slits. There's 3 sets of double slits here, and they let light from the laser pass through. A double slit like this was used to help settle the debate about whether light behaves just as a stream of particles or if it acts like a wave too. If it behaves just as a stream of particles, then there should be exactly 2 spots on the wall behind the slits. However, if it behaves like a wave, you'd expect there to be more spots of light because the waves would interfere with each other, creating bright spots where the peaks align constructively and dark spots where they interfere destructively. So what's the result? Well, testing it out and you see that there's just 2 spots of light, which confirms that light only behaves like a particle. First, take a long strip of paper and tape it to a table so that some is hanging over. Then grab an air compressor with a blowgun attachment. When you gently squeeze the trigger to let out compressed air, that flow of air will lift the paper up. Here are 2 lights with different wavelengths. One is red and one is green. Since colors follow additive mixing, I can combine them to produce yellow. It was actually tough to pick this up on camera since each light has a different intensity, so I moved locations and here's a better shot. You've now seen all 3 videos and it's time to pause to vote in the comments for which one you thought was fake. It's true that mixing red and green light produces yellow. And here's an even closer up shot that hopefully helps you see it the best. It's also true that fast flowing air causes paper that's hanging over a table to lift up. That means when you perform this double slit experiment, the light from the laser does not make only 2 spots on the wall. Instead, the actual result looks like this, a diffraction pattern. And as you can see up close, there's many more patches of light than just 2. It was already established that light can behave like a particle, so this finding proved that light behaves both as a particle and a wave, known as wave-particle duality. I hope you enjoyed this episode and let me know in the comments how you did. I'm also happy to announce that my 2 Truths and Trash Science trivia deck is now back in stock and is also now available for purchase in Canada. Thanks for watching to the end and I'll see you next time.